So the question reads, Zambia recently sealed a debt restructuring deal with her bilateral creditors. As part of austerity measures, all cleaning companies in government health institutions have been directed by the Secretary to the Cabinet to employ hourly and salaried employees. A human resources officer surveyed 180 employees about their satisfaction level with the current health care benefits program. The objective of the study was to establish whether pay type and level of satisfaction with healthcare benefits are related. So, colleagues, as I said, that's the purpose of the chi-square test. You want to find if there's a relationship between two variables. And in this case, one find out if there's a relationship between the pay type and the level of satisfaction with healthcare benefits. So the results of the study are tabulated below. Okay. So these are the results here. And then the chi-square test has been done, all right, which is here. Okay. So part A, state the measurement scale for the variables pay type and level of satisfaction, giving reasons for your answer. All right. So we're going to talk about the measurement scales for both of these things. Oh, let me bring this here. Let's put the question like this. All right. So yes. So the measurement scales for pay type, it's a nominal scale. Okay. What is a nominal scale? It's a scale where it's just only names of the variables and there is no order. Okay. You can't rank one greater than the other. Okay. For example, salary and hourly. You cannot say salary ranks higher than hourly and vice versa. Okay. So that is a nominal scale where the variables cannot be ranked according to any order. All right. It's just the names of the variables. Okay. That's a nominal scale. The level of satisfaction is an ordinal scale. With an ordinal scale, things can be ranked. Have you seen? Because remember, with level of satisfaction, there's dissatisfied, neutral, and satisfied. So you know that dissatisfied is the lowest, neutral is in the middle, then satisfied is the highest. Okay, so with an ordinal scale, there is a ranking for the variables. But with a nominal scale, there is no ranking. Okay, there is no ranking. Have you seen pay type, salary, hourly? There's no ranking between these things here. You can't say one is greater than the other. Okay, but level of satisfaction, this there is a ranking. Any questions, colleagues, before we go to part B? Okay, part B says state the null hypothesis and the alternative hypothesis. So the null hypothesis is usually the claim that is meant to be true, and the alternative hypothesis is the challenging claim. All right, it's a claim that is challenging the null hypothesis. Okay, so for a chi-square test, the null and alternative hypothesis is always standard. Okay, this one, which is H0, this is null hypothesis. Okay, the null hypothesis, it says there is no relationship. Okay, there is no relationship. Okay, so basically saying there's no relationship that exists between an employee's pay type and the reported level of satisfaction. Okay, so always remember, null hypothesis, you're always going to assume there is no relationship. Okay, then alternative hypothesis. Alternative hypothesis, you are going to assume there is actually a relationship. Okay, alternative hypothesis. Okay, you're going to say there is a relationship that exists between the employee's pay type and the reported level of satisfaction. Okay, so always remember for a chi-square test, that's going to be the case all the time. Your null hypothesis, you're going to assume there is no relationship. Okay, you're going to assume there is no relationship. Your alternative hypothesis, you're going to assume that there is actually a relationship. Okay. Any questions on that, colleagues? We're looking at question 16. We're trying to say if there's a relationship between what was this? Between the pay type and level of satisfaction. We're trying to see if there's a relationship between those two variables. So we're conducting a chi-square test, which tests to see if there's a relationship between two variables. Okay. This test is to see if there's a relationship between two variables. So we're just stating what the null hypothesis and the alternative hypothesis are. Okay. So for a chi-square test, the null hypothesis, you're always going to assume there is no relationship between the variables. In this case, there is no relationship between employees' pay type and level of satisfaction. Then the alternative hypothesis always challenges the null hypothesis. So for a chi-square test, the alternative hypothesis will always say there is a relationship. And in our question, this relationship is between employees' pay type and their reported level of satisfaction. Is that okay, madam? So the test has, in this question, the test has already been done for you. Okay, it's already been done for you. So it's more like interpretation of the results. Okay, so we've on part B. So we're now moving to part C. Okay, so it says state the following. Number one, the chi-square test statistic. Okay, so according to this table, have you seen this Pearson chi-square? This is the test statistic. Okay, usually when you're doing this question, if you're doing questions with for chi-square, you have to calculate this test statistic, or you can run a software to calculate it for you. So in this case, the software was run and this was the calculated test statistic. Okay. So what this test statistic is used for is used for helping you make a decision. All right. How it helps you make a decision, you compare it against a critical value. Okay. All these tests, these hypothesis tests, these chi-square tests, okay, all of them, you have to calculate the test statistic and compare it against the critical value. That's one way you can make a decision. Okay. Yes. So in this case, the test statistic that has been calculated already is this 2.66666. Okay. Yes. Any questions before we go to the p-value? Okay. The p-value, which is also called the probability value. So also this p-value, if you don't want to use the test statistic to make a decision, you can use the p-value rule. Okay, the p-value rule says that if your p-value is less than 5%, is less than 5%, reject the null hypothesis. Okay, so what this 5% represents is the 5% chance that your results are random. Okay, your results are just by chance. If your p-value is greater than 5%, then it means there's a likelihood that the results you've got are by chance or they are random. Okay, they are not reliable results. But if your p-value is less than 5%, it means there's less than a 5% chance that your results are by chance. Okay. Yes. So the p-value is a probability value that whatever your test results are by chance. Less than 5%, you've got reliable results because the probability that your results are by chance is less than 5%. So it means your results are credible. But if your p-value is greater than 5%, it means there's a high probability that what your test results are by chance. Are we okay with that, colleagues? If p-value is less than 5%, reject null hypothesis. Results are not by chance. Okay. If your p-value is greater than 5%, accept the null hypothesis because your results could be by chance. Are we okay with this, colleagues? The p-value rule, that's how it's one way of making a decision for your test. Okay. So if your p-value is less than 5%, then it means there's a low probability that your results are by chance. But if it's greater than 5%, high probability that your results are by chance. So in this question here, our p-value is this one here. Have you seen this asimp sig two-sided? Okay, where there's this chi-square value, this is your p-value, colleagues. All right. On this type of tests, you never see it labeled as p-value. Okay, you never see it. You're supposed to know yourself as a statistician. Okay. You just once the results, like once you've done the test through Excel and it gives you results like this, you just come to the p-value. You just come here and see, is this less than 5% or great? That's all you look for, madam, to make a decision. Okay. For all these hypothesis tests, okay, you're going to see more of them even in third year and the other coming years. Even when you're doing your researches, some of your researchers might need you to do some of these tests. So when you do these tests, okay, if you want to see what decision you need to make, either use the test statistic and compare it to the critical value. The critical value is found on table, so you have to get a table and see the critical value and compare. Or you can use the p-value rule and see what is your p-value. Is it less than 5%? Or is it greater than 5%? Okay. Yes. So our p-value here is 0.264. Okay. Then part 3. What is the decision? Okay. So now we'll use the p-value rule to make the decision. Okay. So we look at our p-value, 0.264. Is this greater than 0.05? Because remember, 5% is 0.05. So 0.264 is greater than 0.05. Okay. So there's a high probability that our results are by chance. Okay. So what we're going to say is we do not have sufficient statistical evidence to reject the null hypothesis. This is how you make your decision. It's either you reject the null hypothesis or you accept it. Never say, oh, null hypothesis is true or alternative hypothesis is true. No, your answer always has to be in this format where you say either you reject the null hypothesis or you accept the null hypothesis. So since our p-value is 0.264 is greater than 0.05, we say we do not have sufficient statistical evidence to reject the null hypothesis. Why? Because the probability that our results are by chance is very high. It's higher than 5%. So that's why you can't reject the null hypothesis, because the probability of your results being by chance is high. So you can't reject the null hypothesis. Yes. Any questions? Conclusion regarding the relationship between pay type and level of satisfaction with current healthcare benefits. So remember the null hypothesis. Oh, yes, the null hypothesis, we said there is no relationship that exists. Okay. And from our decision, we didn't have enough evidence to reject the null hypothesis. So basically, what we're saying is there is no statistical significant relationship between the employee's pay type and their level of satisfaction. Okay, that's what part D is saying. All right. Since we failed to reject the null hypothesis, the null hypothesis is saying there's no relationship. All right. So we can conclude that there is no significant relationship between the pay type and the level of satisfaction because our p-value is greater than 5%. Any